Hello, this is Derek, and this is section 10.3, the hyperbola. So hyperbola are really similar to ellipses, and it's good and bad. So there's a bunch of stuff that you already know how to do. The problems are very similar in style, but they're also a bit easy to get mixed up on things because they are very similar. So the way that you can tell a hyperbola from ellipse in terms of the equations is the minus. So if we go back to the ellipse, it looked just like this, right? And the only difference between those two equations is ellipses have a plus and hyperbola have a minus. But remember, with ellipses, a was always going to be the big number, and then a shifted on the equation to tell us that if it's under y, then the major axis is running parallel to y, and if the big number was under x, major axis running parallel to x. That is no longer true for hyperbola. So either A or B can be bigger or smaller. It doesn't tell you anything. In this case, C is going to be our larger number, and I'll go through that down here. But for the A and the B, there's no longer a major and minor on those. A is going to be our center to the vertex, so center to the actual hyperbola. B is going to be what I call center to the other side of the box, because I can never remember the real name for the other side of the box. But it's basically acting like what would have been the other, the minor ellipse. But in this case, again, A or B can be larger or smaller. And then C is the big value. It's running from the center to the focus, but the focus is now inside each of these branches of the hyperbola. So C is actually the largest value, and C, if we drew it in here, C is really, now it's really the Pythagorean theorem. A squared plus B squared would equal C squared. So that's our relationship between those variables. HK is still our center. And then the way that we tell, so back here, remember it was big number under X, it's along X, big number under Y, it's along Y. Here, the way we tell them apart is if it's leading in X, then the transverse X axis is parallel to X, so the axis with all the stuff on it. If it is leading in Y, then transverse axis is parallel to Y. So in this case, the X's and the Y's swap places instead of the A's and the B's swapping places. So that's the part where it looks really similar, but it's just a little bit backwards in these couple of spots. And then the other thing is asymptotes. So the way that we define the hyperbola, to draw it, let me do this one because it's a little bit cleaner, is we have center to the vertex, and that defines one side of this box. And then we have the center to the other side of the box, which again is kind of like the minor side, though it can be bigger or smaller. And then we draw that box, we do this, and then the asymptotes are defined by the corners of that box. And so the way this works is the HK, it's going to shift it. So if this point has moved over here, that's what that HK shift will do. And then the A over B, if you just look, that's A is our rise, B is our run. So it's just plus or minus rise over run right there. So we're just plugging into this asymptote formula, and that will give us the equation of those two lines. And plus or minus because we have a positive slope version and then the negative slope. Okay, so starts off with graphing hyperbola, same as last time. So for this one, we got x squared. I'm going to put that over 1 just to kind of emphasize it's an invisible 1 down there. And so just like last time, because there's no HK showing, it's just x squared and y squared, that means our center is at the origin. For this one, A is 1, and then B would be 4. And so we're going to have a different color. Try this. So A is 1, and then B would be 4. And so that's going to give me kind of that defining the box. I think that pen is going to be too big, so I'll stop doing that. And so the asymptotes are going to run here and there through the corner of the box. And then the vertice, so this one is opening to the sides because it's transverse X. So this would be one branch here and one branch here. Okay, for this next example, it's not quite in the right shape. So same as we saw with ellipses, when this end doesn't equal 1, that means we're going to need to divide everything through by whatever that is. So in this case, those 25s will cancel, and I'll have a y squared. Again, I'm just going to write over 1 for emphasis, minus x squared over 25, and now that equals 1. And so my a is 1, and my b is 5. And again, centered at the origin, but this one will be transverse y, so it'll be opening up and down, and then the y-axis will be cutting through it. So a is 1, so that would be here and here. B is 5, that is here and here. And then again, the way that I knew which way A was running, which way B was running, A is center to the vertex. And so in this case, let me change colors. The vertex is running, again, the hyperbola is going to open up and down. So the vertex is this point right here, and A is going to be that distance. So notice back here, when the hyperbola is opening side to side, A runs along X. But when the hyperbola is opening up and down, then A runs along Y. So in this case, the A will shift with the hyperbola. Okay, so for this one, we're asked to graph the hyperbola again. So the center is going to be, so remember with the formula, we have the negative inside that's reversing how that looks. So when I see a -5 and a +2, it's really going to be a +5 and a -2. But then the other thing is that this is written backwards. It's leading in Y. So we have to be really careful right there to get -2 and +5, because every single thing is backwards. A is going to be 2, and B is going to be 3. And this one is transverse Y, so I'm expecting it to open up and down because it is leading in Y. So let's get our center orientated. So this is going to be -2, 5 right there. And then A is 2, so A is going to run up and down this time because, again, we're opening along parallel to Y. And then B is 3, so that's the other side of the box there. So maybe like this. And then the graph itself, again, this one is the vertex because of the leading in Y. So it would be something like that. And something like that. Okay, so then here's one where it is not in the right form. We gotta go back and do the completing the square. So I'm going to, as I bring this down, I'm going to factor a 4 out of those x terms. And this is very similar to what we did in the last chapter or section with ellipses. And then this time I want to have a minus sign in between. So I'm going to take out a -25. So I'm definitely grabbing that sign. So I'm left with a positive on my y squared, which is then going to flip the sign on that 50. And that would be a -2y. And as I do, I'm going to bring this over. And we'll just roll that into the right-hand side. So now I'll complete the squares. So we got 4x squared, 2x, and then we do half of 2 is 1, and then 1 squared would make 1. And then -25, y squared minus 2y. And then half of 2 is 1 again, 1 squared makes 1 again. And that equals 121. And then this isn't really 1, this is really 4 times 1, so that one is +4. And then that's not really 1, that one's really -25, because that -25 in front. So now if I factor and collect terms, I'm going to have 4x plus 1 squared, 25, y minus 1 squared, and then that is 125 minus 25, which makes 100. And we can divide everything through by the 100 again. So basically same steps as what we saw in the last section. Just we have to be a little extra careful right there when we're factoring out that sign. And so then that gets us to x plus 1 squared over 25 minus y minus 1 squared over 4 equals 1. And so center is going to be at -1, +1. And then A is 5 and B is 2. So to draw that, we're at -1, 1. And then this time it is leading in X, so it's going to open to the sides. So A is going to run side to side. So 1, 2, 3, 4, 5, and 5. B is 2, so 2 and 2. So something like that. And then this would open that way. Okay, so this is the one where we're given the equation and we're asked to find all of the stuff and graph. So center is going to be at 5, -2. So when x is 5, y is -2. It looks like A is 2 and B is 4. And this is leading in X, so it's going to open to the sides. And A was 2 again, so that will be there and there. So those are going to be the vertices. And it looks to be 3, -2 and 7, -2. And then to the other side of the box, that was 4, so that will finish off the graph. Okay, so we got something like that. And then we still need to find the foci. So this is where we're going to do a squared, 2 squared plus b squared. So 4 squared equals c squared. So that's 4 and 16 for 20 equals c squared. And then I would square root both sides on that. And square root of 20, that is the same as 4 times 5 in there. So that would be a 2√5. And that is my exact value for c. And then just to kind of place it on the graph, root 5 is about 2.2, so this would be about 4.4. So that puts us about here, and then there's 2 about there. And again, I'm just doing that to help myself write this next part. So looking at this, everything's on -2, so is the foci. So that means I'm coming off of this 5. Not that we couldn't just look here, but again, backwards. So we're going to go 5, and then from 5, we're either going to go plus 2√5 or we're going to go minus 2√5. So plus or minus 2√5. And again, everything's happening along -2. And oops, I almost forgot the asymptotes. So for the asymptotes, I always just go right back here to my equation and copy it down so I don't get stuff wrong. So y plus 2 equals, I'll grab the slope in a second, plus or minus something, and then x minus 5. And for this one, you can just look at the formula. So when it's a x leading, it's going to be b over a. But you can also just look right here on your graph, and there's our slope. So it's 4 over 2, which is b over a. And 4 over 2 would be 2. Okay, so for this one, sadly, we have to complete the square. So here we go. We will take a 16 out of those y terms, and that's going to leave us y squared minus 2y. And I'll take a -9 out of the x terms, so -9 out front would leave me x squared. And then there's that sign change we've got to be careful of, plus 4. And this 164, I'm just going to kick it over to this side and get it out of the way. And then we'll do 16. It'll be y squared minus 2y. And that'll be a plus 1 there. Half of 2 is 1. 1 squared makes 1. 9 x squared plus 4x. And then half of 4 is 2. And squared will be 4. Equals 164. Right here, we are really adding 16. And right there, we are really subtracting 36. And I'll just sneak it under there because I'm a lot of room. So 16, y minus 1 when I factor, minus 9, x plus 2. And then 164, and that made 180 minus 36, 144, yeah. So combining, I get 144. And then remember, whatever's over here, we need it to be 1. So we just divide everything by the 144. And then you pretty much count on 16 is going to go into this nice. So, to reduce the fraction, just go 16 into 144, and you're going to find it's probably going to go whatever that number is right there. So this ends up y minus 1 squared, and that will end up 9 times. And so then 9 goes into 144 16 times. And that equals 1. So from there, now I know A is 3 and I know B is 4. So 3 squared plus 4 squared makes C squared. 9 and 16, that's 25 is C squared. So C is actually a nice number this time. C is 5. And then, oops, I should have parentheses right there. And then I think with that, I can get everything else. So our center is at, and again, careful not to go 1, -2, because it's -2 and 1. And then let me get that graphed. So x is -2, y is 1. And then we know A is 3. So count 1, 2, 3, and down 1, 2, 3. And so those are going to be the vertices. So we got one here at -2, -2. And we have a second one at -2, 4, it looks like. And then the foci. So those are going to be C is 5, right there and right there. So I can actually just read those right off the graph too. And so they're both on -2. And really what we're doing here, let me draw on the B side of this just so I can kind of get the graph finished and out of the way. Okay, so the graph would look something like that. So then what we're doing is we're just from this, where this is at 1, we're going up 5, so that would be at 6. And then where this is at 1, we're going down 5, so that puts us at -4. And so it's that same up down that we did with the roots. It's just now it's a nice clean number so we can get actual points. Okay, and then like the last section, we're given information about the hyperbola and then asked to find the equation. So determine the equation in standard form of a hyperbola that satisfies the given conditions. So we have foci at these 2 points and the slope of an asymptote. So the foci, let's go ahead and graph those. And again, even if they don't give you a graph, for me the graph is really helpful for just kind of getting orientated. So x is -3 and y is -6 for one of them, and then -3, 4 for the other. Okay, so if this is the foci, that tells me that my graph is going to be opening up and down. And then I also know that midway between those 2 points is going to be the center. And so you can kind of see in the y values, this is going from -6 to 4. So that would be a total of 10. So halfway in between it either be 5 below or 5 above, however you want to think of it. But so that puts the center at -3, -1. So there's my HK. And then the other thing I would need is my A and my B, and that fills in my formula. So from the center, they told us that our slope was, what, 3/4. And so that is our rise over our run. Or, because this one is opening up and down, that is also known as our A over B. And so what that's telling me is that A is 3 and B is 4. And then I'm going to draw that in over here just to try to make that make a little bit more sense. Again, I think the graph helps with that. And so the asymptote is saying the run is from here is going to be 4, and the rise is going to be 3. And we have the same thing on this side. And then we'll have the same slope but negative. And so that means, again, this was opening up and down. And so once I get those asymptotes in, then I can see from here to here, that A is 3. From here to here, that B is 4. You don't need the picture to do it, but hopefully looking at that distance being A and that distance being B, that makes sense why that would be the slope. So our equation, it's opening transverse y, so we want y and then plus 1 minus minus, and then minus x minus minus, so plus 3. And then a was 3, so squared makes 9, and b was 4, so squared makes 16. Okay, for this one, find the equation of a hyperbola with a focus at 7, 1. X is 7, y is -1, a vertex at 6, 1, -1, and a center at 4, -1. So what those couple of dots give me is, this is center to vertex, so I know A is 2, and this one is center to focus, so I know C is 3. And with that, I can get B, and I can also fill in the other side of this. And so B will be 2 squared plus B squared makes 3 squared. So B squared will be 9 minus 4, which is 5. So B, for graphing purposes, is about root 5, which is about 2.2. So we end up with something like that. And then this parabola will be opening, hyperbola would be opening to the sides. Because it's transverse x, everything's parallel to x. And so then our equation is going to be x, center was right there, hk, so x minus 4, and then minus y minus the negative, so plus 1 equals 1. And let's see, a was 2, so a squared would be 4, and b squared was 5. So there is our equation.